Now, ring topology. Every node is connected to two nodes on either side of it. All nodes take a continuous loop, so you got effectively that ring. Data passes around the ring. Now, the node can transmit data if it has a token. There's a token that passes. I'm going to reference token ring in specific here. Token ring creates a logical 24-bit control frame, just a little bit of data. It passes around the ring. Whoever holds that control frame, whoever has it, is the only one that can transmit. So there are no collisions because only one machine can transmit at a time. Now, if there's a break in the cable, you can't communicate past that break. It stops communication at that point. I mentioned ring, I mentioned bus. These are old forms. We don't do bus topologies nowadays. Now, Ethernet is still a logical bus no matter what we do. Token ring is still a logical ring no matter what we do. These are physical topologies. We've replaced them with the star topology. Ethernet, we put a hub or switch in the center. We now have a star. It's still going to logically work just like that bus, machine to machine to machine to machine. It's still going to travel, and the ends of it are going to be the terminators. It's still going to act like that bus, but it's done with a hub or switch. Token ring, instead of having a hub, we have an MSAU or MAU, the multi-station access unit. It's in the center. It contains the collapsed ring inside. When you get to the end, the last one on that MAU, it goes back to the beginning. Starts back with the first one. So that ring is effectively there inside. We wire it like a physical star, still operates like a logical ring. Now, a mesh topology. Look at how many wires we have there. We've got 6 computers. You know how many wires that is? That's 15 wires. Now that seems like a lot, but maybe not an insurmountable amount. Well, how about we had 10 computers? It would jump from 15 to 45 wires, 45 cables. Every node has independent connections to every other node. Incredibly fault tolerant. How about we go to 100 machines? That's 4,950 cables. I can just see that cable tray going down the center of the building. It's going to be this wide with a big bundle of cables in it. I feel sorry for the guy who has to wire everything. And on the back of every computer, you've got to have a card in there that can support 99 network cables for each machine. That's not real scalable. The nodes would need multiple network cards, maybe more than they can hold. Well, let's see. On a PCI card, we can hold 8 functions, and we can have 5 of them. So that'd be 40 network cards. How do we get the other 59 connections for 100 machines? I guess PCIe is going to have to work some double duty there. It's just not practical. It's a complex wiring scheme. It says it's most often used in wide area or campus links. This last bullet is going to fix a lot of things because I can't agree with that until we get to this last bullet, and it's that it might not be fully meshed. It might be a partial mesh. Some redundancy is added. Maybe not entire redundancy to every link, but get rid of just a single point of failure. Maybe everyone has at least 2 paths to get to everything. We look at the top and bottom one. That bottom one can get to the top by going straight to it. It can go one machine to the left and then go to it and go a machine to the left, another machine to the left and go to it and go a machine to the right and then go to it and go a machine to the right, another one up and then get to it. It can go to the one to its right and then go over to its, all the way over to the left and up to it, go to the right, up to the upper left and then get to it. I think you guys get the idea. It can be pretty messy, but there's so many redundant paths. A partial mesh might only have 2 paths for each machine to every other. Not in this case, 1, 2, 3, 4, 5 paths to each machine. Okay, probably more than that. I'm just making it simple. I'm probably missing a few possibilities, such as crossing from one to another, multiple pathings that way. So probably upwards of about 9 paths to get to its final destination. Okay, that's excessive. Very few organizations ever need that. So maybe just two connections available, what might be called a redundant backbone. So there's two paths to all the main machines. That would still qualify as a partial mesh. And that is realistic and does appear in the real world. A full mesh is very rare. It's pretty much an academic exercise. Now, hybrid technology says just combine any two of the above. You know, maybe you have a mesh and a ring. Maybe you have a mesh and a bus. Maybe you got that star with a bus, or star with a ring, or star with a mesh. Any combination like that would be a hybrid topology.